professor and your small YouTuber. This is again Engineer Sotero Nepomuceno Jr., BS Chemical Engineering profession, and a registered chemical engineer. Okay, going back to the topics that we're able to discuss yung mga palangka, it's gonna be Lee Chatelier's principle, right? Okay, Lee Chatelier's principle. Ganon. Lee Chatelier's principle. Okay, like that. Again, recall the theory. Whenever the stress is applied to a system of equilibrium, the equilibrium will shift in such a way to reduce the stress. Okay, for example, if I will try to have the Haber process, you remember the Haber process that is reacting ammonia. No, it's not reacting ammonia, it's reacting nitrogen gas and hydrogen gas. Let's say I have nitrogen gas plus hydrogen gas is equals to ammonia. Okay, this process is very useful in the production of fertilizers. Okay, something like that. Okay, and then we need to balance the chemical equation, nitrogen 2 in the left and nitrogen 2 in the right. And you have to balance the equation, put 3 in the hydrogen, so hydrogen balance 6 atoms balance, perfectly balanced. Then this is at 150 atmosphere pressure, something like that. Okay, and then it will yield ammonia. Okay, this one. Okay, for fertilizers. Okay, something like that. For example, guys, we have the stresses. Okay, like this. Okay, the stresses, as I told you a while ago, it's gonna be the temperature. Okay, or should we say the conditions, right? But in here, we treat them as stresses. Okay, temperature, pressure, something like that. We have the volume. Okay, we have the number of moles. Okay, and we have also number of moles. Okay, the catalysts and the inhibitor. Okay, inhibitor. You know the inhibitor? These are chemicals that will be added to a chemical reaction to slow down the rate of the reaction. Okay, inhibitor, the reverse of a catalyst, because the catalyst is used to increase or speed up the rate of a chemical reaction. Okay, something like that. Inhibitor. Okay, now in here, this is our original chemical reaction. Guys, on the spot kayo po, guys. Okay, now if I have to increase the temperature in our reactant, what will happen? Okay, will it shift to the right? It will shift to the left. Here, left and right. Here, ganon. What will happen? Then secondly, if we increase the pressure, the reactant will shift to the right or the product will shift to the left. Things like this. Okay. Now, if we increase the volume of our nitrogen, what will happen to our ammonia? What will happen to our hydrogen? Like this. The nature condition principle, guys, is very theoretical, not really computation, not problem solving. You need only to understand the theories, the chemical relationships. Something like that, okay? The number of moles. If we increase the number of moles of hydrogen, what will happen to the hydrogen? It will shift to the right, it will shift to the left, something like that. If we add a catalyst and the inhibitors, what will happen to your... if I will add catalyst in our reactant, what will happen to my reaction? It will shift to the right, it will shift to the left, something like that. If I will add an inhibitor also, will the reactant will shift to the right or to the left, something like that. To reduce the stress, meaning to balance, to establish equilibrium. Okay? Equilibrium means state of equilibrium. State of equilibrium. Okay? Meaning the rate of the backward reaction will be equal to the rate of the forward reduction, meaning your process is undergoing a steady state flow. Steady state flow in which the time is not considered, meaning independent of time. When we have the state of dynamic equilibrium, meaning our process is independent with time, and we will always treat that as steady state flow. Normally, the steady state flow, if we try to put this discussion to fluid flow or the unit operations, remember, the momentum transfer, a transfer of fluid governed by velocity changes, okay, the flow will be laminar, smooth flow. Remember that one? That if you compute the Reynolds number should always be lesser than 2200, something like that. Because if it will go to 2200, it will develop an EDIS like that. Too much, scattering of the particles and molecules in the body, it will become turbulent above 2200 Reynolds number. Now, in this process of equilibrium, it's understood to be below 2200 Reynolds number, meaning to say the flow will be laminar and a steady state flow. So in that situation, we are now following the theory of independent of time. Time will not be considered here. Okay, that's why there's no stresses time involved here. Okay, there's no time and there's no concentration, right? Because in this state of equilibrium also, the concentration of your reactant and your product will no longer change in the state of dynamic equilibrium. You get the point? Okay, something else. That's why we can establish our equilibrium constant for that. And we can derive an equation for that also if we treat an equilibrium process or state of equilibrium. Okay, steady state shock. And then if you apply this to the unit operation of, momentum transfer, fluid mechanics, blah, 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 chuba, chu, then we will apply the law of continuity. Law of continuity. For example, potential energy plus kinetic energy, plus the pneumatic pressure is equal to the kinetic energy 2 plus potential energy 2 plus pneumatic pressure 2, like that, and equate that equation, and that is called Bernoulli theorem of fluid flow. So that is law of continuity still governing the law of state of equilibrium. If you found the equal sign in your equation, you treat your equation will be in equilibrium, equality, the two dashes. You put that in your chemical reactions. Equals or equal sign meaning equilibrium. That's the purpose there, so that you can find the unknown quantities of your simple equation, or could it be algebraic linear expression, or could it be a science mathematical equation or expression, if there is this equality sign. So equilibrium, something like that. You get the point? Okay, like this. So that's why Lee-Chapelius principle are always focusing on the state of equilibrium. Okay? See, whenever a stress is applied to a system of equilibrium, okay, the equilibrium will shift in such a way to reduce the stress. Diba? Klaro siya. Okay. Like that. Okay, this is the brief introduction of Lee Chapelier's principle, discovered by Mr. Chapeliers. Lee is his first name, and his last name is Chapelier. He discovered this principle in 19th century, 1901. Okay, like that. Get the point? Any questions so far, mga palangga? If you like this video, you can comment down below in the comment section, and you can share to anybody else the introduction of Literature Principle in General Chemistry Lectures. And I thank you. You can click also the bell notification for newest updates of I Am a Senior Original Voice, and then you can subscribe also to my YouTube channel if you want also. Thank you so much. Bye-bye. See you later for my next vlog. Okay. Diba?